is an extension of our industrial wireless solutions. You're probably very familiar with our long distance, high speed industrial wireless radios. Now, today we're going to talk about using wire for a wireless system. Okay, and there's plenty of reasons for doing that. We'll get into all of that over the next 30 minutes. All right, so without further ado, we're going to talk about radiating cable, or sometimes known as leaky feeder in certain parts of the world. Okay, a radiating cable is a cable that is designed to leak, right? So most coaxial cables that we use for wireless are designed not to leak. So they have got good shielding and good grounding and so on. Well, for a leaky feeder cable, we manufacture holes or slots into the actual shield itself, right? So what you get is a radio frequency transmitting out one direction of the cable. Right. So it essentially acts as a long, flexible antenna. Okay. So you know how regular antennas essentially spray radio frequency in one direction or sometimes in all directions? Well, leaky feeders are a little bit more like a garden hose, right? So they have holes on one side of the cable, which sort of, if you will, spray radio frequency in a specific direction over a very short distance. Okay. So that's great if you've got tricky paths or situations where regular antennas don't work very well. So for example, machines that move along a specific path, automotive assembly plants where you have your assembly systems moving along a specific path, cranes, for example, that move again along a specific path. As well as wireless systems that need to go down a tunnel that isn't 100% straight. So all these can be very easily solved using leaky feeder cables. So what's a radiating cable? Essentially, it's a long flexible antenna, right? Like I mentioned. It's got slots cut into the outer conductor or the shield in a specific direction. So our leaky feeder cables, if you look carefully, will have a groove on the jacket, right, on the opposite side. So when you install the leaky feeder cable, make sure the groove is in the opposite direction of where you want your RF to emerge. I'll get into more detail on that in a second. Okay. So why would you run wire for a wireless system? Okay. So there are situations where traditional antennas are not practical or not possible. I'll give you an example. A highly enclosed area, for example, we've got a bunch of aluminum smelters all over the world that run antennas. You get a lot of reflections and a lot of what we call multi-path problems with enclosed areas. You get essentially radio signals reflected off metal walls, which will then confuse the antennas on the receiving radio. So in situations like that, leaky feeder cable is a really good solution. You might also have, for example, warehouses with automated storage and retrieval systems, okay, where line of sight can be a challenge. Okay, when the racks are full versus when they're not full, you get different radio frequency distribution patterns from standard antennas. But with a leaky feeder cable, you get very regular, very predictable radio frequency distribution. Okay. So when you need to maintain signal strength, okay, as a device moves, with traditional antennas that can be a challenge, okay, because of multipath, because of obstructions. So the solutions to that, you can use diversity antennas or MIMO antennas, or as a very stable solution, you can also use radiating cable. So I'll skip through all these words. So, but what you're looking for essentially for installation of radiating cables is situations where you have confined spaces, okay, where you don't have good line of sight from end to end. Or you might have monorail systems in, say, automotive plants or for cranes, and so on. And where you have specific machines, they can be small machines even, okay, but when you need good predictable signal, nothing beats a radiating cable. I'll show you some of the projects that we've done. So the cognac plant in France has bottling machines, and obviously these machines rotate at a very high speed. So the most reliable way of running wireless is to run a ring of leaky feeder along the path of the movement of the bottle filling heads. We've done the same for Bacardi as well. We've got a nuclear power plant in Spain where we've got a wagon that's traveling along a tunnel, not a very long tunnel. I think it was about 50 meters only, but it's perfect for a leaky feeder application. A conveyor manufacturer called Elco, based out of Italy, uses a leaky feeder solution as well. You can see the picture right at the bottom there. We've got moving conveyors that's moving at extremely high speed, so you can't see the video here, but these things are rotating at probably 2 revolutions per second. Okay. So very high speed. We've got similar applications in baggage handling systems, okay, for a manufacturer called ELSA. We've done a crane application for Rio Tinto in Canada. So most of our cranes in Asia, I think we still do with open antennas. Okay, but for situations where you have a very noisy, a very busy radio frequency. So continuing on, we've got amusement park OEMs that have installed rides in Six Flags, famous amusement park in the US. They've got some in Universal Studios in Japan as well, I believe, running safety I/O over radiating cable. Okay. So the rides are obviously, because they're moving, it's not practical to have them run over a wire. Right. So wireless using leaky feeders is still the best solution. In that application, we've got CIP safety protocol running over guard logics. I believe for the Six Flags project, we had 14 CIP safety connections. So we're also running Profinet, which is an Ethernet-based protocol from Siemens, for the Porsche plant in Germany. And we've done a whole bunch of slip ring replacements as well. This for tumbling machines in food manufacturers. We've got rotating kilns for mining operations, just all sorts. Okay. So broken down into its most basic elements, this is what the leaky feeder system looks like. So at the top here, you've got a radio. This is the moving radio, the moving part of the system, if you will, with an omni antenna. And all along the path of your moving radio, you've got static radios, okay, with leaky feeder cables having overlap from one radio to another. So it uses the fast roam feature of ProSoft radios, which means the radio, as it is associated to the left master, can very quickly roam to the right master as it passes the overlap area. Okay. We conservatively say 50 milliseconds, but our latest designs enable fast roam in actually under 10 milliseconds. So this is why it's safe to run safety protocols over it. We've got customers running Ethernet IP IOs, okay, over the leaky feeder very reliably. So depending on the frequency that you use, you can use up to 125 meters per segment. So every black line here is about 125 meters. So you've got a total of about 500 meters in this diagram. In terms of parts, for your convenience, we do have pre-terminated cables of a specific length. So these come with your coax connectors or pre-terminated. That can be connected directly to your conversion cables and straight to your radios. Okay. Or we also have bulk cables. Okay, these are for projects that need longer distances or distances that can only be determined on site. Okay. So we also provide all the terminating tools, the terminators as well, wire strippers, things like that. And for installation, we also provide spacers and hangers and clips. And I'll give you a picture of what these are shortly during the installation section of this webinar. Just to give you a bit of a technical view of our tests. So we've got good performance of up to 200 meters per segment on the IHG radio. So this is your 2.4 gigahertz high power radio. And your packet per second performance is up to 6,000 packets per second. So just to give you an idea what that means, that is 1,500 analog modules running at 500 millisecond RPI. Okay, so that's 1,500 analog modules. Okay, that's a lot of traffic. So we're actually in conversation with customers to run high definition video over Leaky Feeder for certain crane applications. So the Leaky Feeder carries a lot of data, okay, even though it's wireless. So we've covered some of this already. I'm just going to move on to a typical automotive project. So this would be for a typical assembly line. Can be used for a paint line as well. You have 66 car carriers, okay, more than 70 radios scattered throughout the path of the car carriers, covering a total distance of more than 500 meters. So this is an actual project. We've got a lot of these sort of at the bidding stage right now in various countries. Some details about actual performance. So this will give you a good idea of what can be achieved. Okay, at 2.4 gigahertz, we've run it up to, in fact, 200 meters. Signal strengths are very, very good. The lowest we've seen is about -63. And without channel bonding, so you've got a typical channel width of 20 megahertz, we can carry up to 5,000 packets per second. Okay, with channel bonding, we can carry up to 6,000. So all these numbers, if they don't mean anything to you, don't worry about it. ProSoft Technology is always available to help you at the design stage, to help you design your Leaky Feeder system or radiating cable system. Some notes about installation. For best roaming performance, try and have a 1 meter overlap over here with between the two segments, and always remember to install a 50 ohm terminator resistor at the end of each segment. Okay, so all these parts are provided by ProSoft. I'm just going to skip some of these test results and give you a visual of how you cover 1.5 kilometers. So you can simply use 6 radios. Each radio with 2 segments, overlapping segments, would cover about 1.5 kilometers. So we've got a whole bunch of supporting documents available for download if you'd like to have a look, get more detail on how Leaky Feeder works and how to install them. Okay, they come with guides as well on how you should strip your bulk cable, what tools you should be using, and typical best practices for installing connectors at site. It's pretty much, foolproof. Okay. There's also guides on the spacing of each connector, of each hanger, if you were to install a long run of Leaky Feeder cable. Okay. So I'm going to get into some details now about the actual radiating cable installation here. Yeah, pardon the spelling mistake there. So we recommend a minimum of 5 centimeters from the wall. We recommend 8 centimeters or more, and recommend using clips and spacers that we can provide as part of your Leaky Feeder kit. Okay. Should use a clip every 1 meter, okay, and every 10 meters we recommend using a stronger hanger. So this would be for installations, say in tunnels where fire might be a potential risk. So you want the stronger hangers, which are metal reinforced, every 10 meters in case these plastic clips melt during a fire. So all these are described in the installation guide. The mobile antenna, okay, should be installed between 2 cm and 2 meters for best performance. Okay, so this is the antenna that is attached to the mobile part of your system. Okay, we've tested up to 18 meters. Okay, so the coverage can be very long. but you do get some signal degradation, so you won't be able to get your full 6,000 packets per second high performance at that sort of distances. So try and keep them short, within an arm's length, if you will. Every leaky feeder cable segment also has a specific coverage zones. So towards the end of a cable, you get very little coverage. So that's the reason why we recommend at least 1 meter worth of overlap. If you've got room for more, then so much better. And as mentioned before, remember that leaky feeder cable or radiating cables radiate the radio frequencies only in one direction. Okay, so it's in the opposite direction of the slot on the jacket. If you were to install radiating cables in tunnels or any sort of enclosed space, we recommend leaving 1 meter from the edge of the walls. Okay, recommend not installing them in ducts if possible. This will help you get best signal performance. So this is what a hanger looks like. It's got a reinforced metal band that will help keep the cable up. And if you look carefully at the cable, you will see an embossed slot on the jacket. Okay? So this indicates the opposite direction to which the radiating cable radio frequencies will be radiated out. Okay? So if you're installing them not in a horizontal or vertical positions, to make sure the cable is rotated in the right direction so that you get signals radiated out in the correct direction. Just to give you a view of how your electromagnetic field lines radiate out of the cable. Okay, you get best signals along the central axis, straight perpendicular out of the cable, and then the signals degrade as you veer away from this central axis. Okay, so make sure the installation is as accurate as possible for best performance. Other basic simple things, there's a maximum bending radius for the cables as described in the data sheet. So make sure the installation adheres to this bending radius, and also avoid having twisted cables. Okay? Keep the slots and the holes aligned. The holes that's in the copper jacket, make sure they're aligned in the direction where you want the radio frequency signals to emerge. We've got two types of cables. A low frequency cable suitable for 2.4 gigahertz installations, and a high frequency cable suitable for 5 gigahertz installations. So if you have any questions or if you're not sure about which cable to order, please let us know. We'll be happy to provide some feedback and some guidance on cable selections. Okay, these are again just some pictures of the insides of your radiating cables, and that's a quick summary of how leaky feeder or radiating cable technology is used in our industrial world. If you have any questions, we'll be happy to take them. So we've got one question coming in from Dale. Okay, so are other frequencies available for VHF, for example? So ProSoft doesn't deal with VHF radios, so we currently don't carry the VHF leaky feeder radiating cable line. But another question, how is transmitting power spread along the cable? Okay, so we have purposely limited the distance to 200 meters to ensure that you don't have too much signal degradation towards the end of the cable. But essentially, yes, you get signals do degrade as the cable length towards the end of the cable length. So if you keep within our 200 meters specified distance, essentially you will see no degradation of signal. Another question, is the system suitable for EX-rated environments? Well, Leaky Feeder is a passive component, so it doesn't actually generate power. The radios themselves are rated for Class 1 Division 2 or Zone 2. So as long as you stick within that zone, you'll be all right. How about outdoor environments for Leaky Feeder? Yes, the cable itself is designed for outdoor installation. So, like I mentioned before, we've got lots of installations for cranes. Tunnels are not exactly outdoors, but yeah, no problem being exposed to rain and sun. And obviously, all your coaxial connections, like your terminating resistors, which are a coaxial connection, all that needs to be waterproof. How about corrosive atmospheres, for example, H2S? Okay, I'll have to have a look at the characteristics of the cable, whether it's H2S resistant or not. But the cables are halogen free and low smoke, so they are designed for installations in tunnels. I'm just not sure about hydrogen sulfide. Now, if you'd like, you can go into the ProSoft website, or well, you can even just Google ProSoft Radiating Cable, and maybe I can just do that right now. So if you just do a search for radiating cable in your favorite search engines with the ProSoft name, you'll find all the information you need. This one, for example, is the high frequency 5 gigahertz terminated cable. And just to answer your question on whether it's suitable for your installation in an H2S environment. Okay, it doesn't say specifically here, so I'll have to get back to you, Dale, on this question. Okay, can it operate underwater? No, it can't. So radio frequencies don't work underwater. Yeah, you have to use alternate technology like sonar or something. But RF does not work underwater. Okay, another question: is it only working under 2.4 and 5 gigahertz, mostly for Wi-Fi communications? Yeah, so the two types of cables that we carry right now are 2.4 and 5. You can use them for anything. 99% of our installations are for Wi-Fi, but you can also use them for other 2.4 gigahertz installations. So, for example, you can use them for Bluetooth, or you can use them for frequency hopping radios. Yeah, anything that uses 2.4 or 5 gigahertz. So I've got a question again. Do you have equipment to check for SWR? I guess that means VSWR. We do, but they are not manufactured by ProSoft. So it is third-party equipment. So you can use any coaxial or RF test equipment that you like. Okay, so if we don't have any other questions, we're always reachable from our website. So if you're not sure who your local contact is, you can always go to our website and go to About Us, Contact Us. And we've got individual country contacts. So either contact your local distributor or contact your local ProSoft sales manager, or you can just send an email to any of these, and we typically respond within hours. So thanks again for spending your time with us this morning or this afternoon.